the calculator. So this will be great. And you'll be like, oh, great. I don't need this table anymore. But like I said, it's good to know how to do the table. Okay, so here's your little notes section using a graphing calculator. And you want to memorize this portion, calculator. Okay. 2 different things that you need to know if they give you, okay? If you're asked to find the area or the probability. If you're asked to find the area or the probability. So, for example, they give you something like this. They give you the z being negative 1.5 and 2.3, and you are asked to find the area between them, okay? Simple, super simple. You go to second vars. So I'll hit it for you. Vars is right next to the word clear. Go to second vars, and up pops, do you see how it says normal PDF, normal CDF, inverse norm? You see those things, okay? Your best friend is normal CDF. So you type in norm CDF, I actually just call it norm CDF. And there are 4 things that you're gonna have to do. If you have an old calculator, you actually have to type it in. So if I hit norm CDF, do you see how it says lower, upper, mu, sigma, and paste? You see those 4 things? Okay, so I'm going to tell you what it is. Your lower bound would be your lower z. So in this case, which one of those is the lower one? So negative 1.5, you would put right there. Your upper is the upper z, which is 2.3. Your mu is always going to be 0 because we're working on the z-score. And your standard deviation is always going to be 1. So 0, 1. Enter, 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 hit paste. And it, for the old calculators, you actually have to type it in with commas. But hit enter, and what do you see there? 0.9225. What did you used to have to do on the green sheet? You used to have to, like, what? Find the area of 2.3 and then find the area up to negative 1.5 and then do what with those 2? Subtract. They just did it for you. You don't even have to subtract anymore. You don't have to do nothing. It's done. Norm CDF. Okay. If it's not working, I'll help you out in a minute. Let's do another one. What if I gave it to you like this? Let's say I gave you the area and I said, find the area to the right of a z-score of negative 0.25. So something like this. Okay. So you still go to second vars, but let me explain the 4 numbers that you're going to put in now. You still go to norm CDF. Norm CDF finds the area. Norm CDF. Okay. The first number is always the lower z. What's your lower z here? What's the low z on the left side? What's the lower? Negative 2.5 or negative 0.25. The second number is the upper z. Well, if I'm going off into infinity, what do I write? Well, the magic number to write is a very large number. Just write 999. Just type 999. Your mean and your standard deviation, you always end 0, 1. So we're going to do that now. Second norm CDF, negative 0.25, 999, paste, enter, 0.5987. You should always round to that. And again, what did we used to have to do? We had to go to our chart, go find this guy, and then subtract it from 1. We don't have to do that anymore. Okay? Do you know what it would be if I flipped it the other way? Like, what would I do if I did a left Z? I'll do one for you. What if I had my Z on the left? So what if I had like 2.6? I want you to find this area. Okay? Still go to norm CDF. Ooh. Norm CDF. That's your best friend. What would be your low Z? Nope.
No. You put that as well.
Not 999, but what's on the left? Negative 999. What would be your upper then z that you're going to? 2.601. Tell me what you get there. Let's see. Norm CDF, negative 999, 2.6, and 0.9953. That's how you do it from now on. It's so simple. You could look at your little green sheet right now, go to 0.6, it's going to be 0.9953. Your calculator is much more accurate, though. It gives much more precise decimals, so that's why we use it. Because there is the lowest z that I could possibly be. I do negative 9999. Okay. All right. Then, what if I want to work backwards? What if I want to find the z? Like they give me the area and I need to find the z. Okay. So write this one down. Find the z-score now. And so what we used to have to do is we would have to go to this green sheet and we'd have to go look for the area and then write the z like that. We don't have to do that anymore. This is awesome. Okay. So let me pick one right here. Let's find a z with an area that has 0.8766, something like that. Let's say this is 0.8766. Okay, and I want to find the z that has the area of 0.8766 associated. So this one is, you do have to keep in mind, you always have to work left to right. So this is a left to right area, which is great. So it's nice and easy for me, okay? But what you do is you don't use norm CDF. You still go into second vars. Use what's called inverse the norm, meaning I want to undo the area and find the z. So if I go to second vars, do you see where it says inverse norm, INV norm? Okay. What does it say comes up here? It says what? Area, right? That area has to be a left-sided area. So you might want to make note of that. The area must be left-sided. So if I put the area in there and I'm going to put 0.8766, keep the mu as 0, keep the sigma, standard deviation as 1, hit paste, inverse norm, 0.876601. I'm just trying to write this down so you can all look at it later. And I get, what's my z? 1.1, I'm going to go to 6. That's my z. Easy, okay? Just do a right-hand one just to show you, because I always want you to make sure there's a right-hand one. What if I had an area of, let's make it really tiny, like 0.0316. There's my area. And I want you to tell me what that z is. Okay? Well, there's, again, a couple options here, but what you're supposed to do is find that area. Does that make sense to you? So you have to find the left-sided area. This is a right-sided area. It's to the right. I need the left-sided area. So what do we always do? We subtract it from what? 1 minus 0.0316 is 0.9684. And that's what you put in the calculator. You inverse norm 0.9684, comma 0, comma 1. And tell me what we get. Let's see if it's the same as me.
1.86.
1.86 is correct. That's your z. Now, had you inverse norm this, what do you think you would get? You would get a negative z, but what you need to realize, it's on the right and you could change it to positive. So some of my students last year, that made sense to them. So they would just put this in here and be like, well, it's on the right-hand side, so I'll just change it to a positive. You can do that. But I would just get into the habit of doing the same thing over and over again. So how do you feel about this? Easier. I know it's like, but I'm so used to the green thing. I know, but now it's just going to become so much more efficient for you and quicker for you to just do it in the calculator. All right. Now, that's the little first part of the notes. Here's the actual 3 steps that we're going to do from now on in everything we do concerning area or finding z problems or whatever. Finding area, under norm distribution. There's 3 steps. I'm sorry I'm writing it so short under here, but that's all I got, the space. Okay. Number 1, and most of you were doing this on the test, which I'm thankful for, you always want to draw in shade because you want to have an idea of if it's a left-sided, is it an in-between, is it a right-sided? You definitely want to draw and shade it. It just makes more sense when you draw and you shade, okay? Step 2, you are going to convert everything to a z-score. Okay, and if you don't remember that formula, I'm going to write it now. You should remember it. It'll look familiar to you. To convert to a z-score, you write z equals x minus mu over standard deviation. Remember doing that? You've done it. You did a whole worksheet on it. Yeah, I know it's been a while, but I promise you from now on, you're just converting everything to z's because it's just easier to work on a z rather than work on like an 80, 85. We convert everything to z because it makes it all one nice table. So, and then the third thing would be then use your calculator and find the area or the z, depending on what they ask you for. Okay, that's all we're doing. And so we're going to do 4 problems right now, which you had the 4 from yesterday. These are the ones that you cut and paste because we're kindergartners. We like to cut and paste. And I'm going to try to squeeze it in here if I can. And then that's it for today. So let's take our first one. An average adult. An average adult has 5.2 liters of blood. Don't know if you know this, but when you're pregnant, you have more than that because you are all. I didn't know this. I mean, I should have. I have another human being in my belly, but you have way more blood. You have a ton more blood than that. 5.2 liters of blood is your average adults. Assume the variable is normally distributed. So this is what you definitely need to see, or you can't do what we're doing. Everything should be normally distributed. Has a standard deviation of 0.3. Find the percentage of people who have more than 5.4 liters of blood in their system. Okay, so first thing we do is we need to kind of draw this in an idea, but actually I should have probably wrote that backwards. We want to find the percentage of people who have more than 5.4. Would you agree to that? More than 5.4? Okay. The problem is this is not a Z. Would you agree? So what you're doing is you're going to convert everything to Z's. So we are going to convert, we're going to get the Z using the formula x minus mu over standard deviation. So 5.4 is my x. What's my mean? What's the average? 5.2. And what's the standard deviation? 0.3. Okay. Using my handy dandy calculator, I'm going to convert that and I get, divided by 0.3, I get 0.6666. So with z-score, you probably want to go to at least 2 or 3 decimals. So I'm going to go 0.667. So on my little normal distribution here, remember this is 0. Where would 0.667 lie? To the right of 0, to the left? This isn't a hard question. To the right. So here's my z is 0.667. Okay. Now, I want to find the percentage of people who have, look at this word, more than that z-score, more than 5.4. This is equivalent to 5.4 liters of blood. This is the z. So would I shade to the right of this or to the left of it? More than, wouldn't that make sense to the right? Okay. So I want to find the area or find the percentage, area, probability. Those are all the same words in statistics. Percentage, area, probability, all the same words. If you need to write that out because you're going to be area, probability, percentage, all the same words. Okay. So now that we've shaded it, step number 2, now we use our calculator. So to find area, do you use norm CDF or inverse norm? Norm CDF finds area, inverse finds the Z. So norm CDF, what would be my lower bound number, my lower bound Z? But look at where it's shaded. 0.667. And then where would be my higher bound Z? 999.01. Okay, put that in our calculator. $9,999,001, easy. I got, God bless you, 0.2524. Would you agree? 0.2524, or that is equivalent to what percentage of people? 25.24% of people have more than 5.4 liters of blood inside of their body, according to that. Okay? This is the first time you're doing it, so if you're like, I don't know what you did, you're going to get, I promise you, you're just going to get so used to this, and you're like, okay, I got this now. All right, let's do example 2. Each month, an American household generates an average of 28 pounds of newspapers alone for garbage or recycling. Didn't know that either, did you? Assume the variable is approximately normally distributed. We need that there or we can't do what we're doing. Has a standard deviation of 2 pounds. If a household is selected at random, find the probability of it generating between 27 and 31 pounds or more than 30.2 pounds. So this is actually 2 problems in one. We're going to do both of them. So this side I'll do my A and this side I'll do my B. Okay. So again, we no longer work with the numbers. We work on a Z-score. So everything needs to be converted to Z's, y'all. And it's not that hard. It really isn't. You've done this before. You convert. I need this number converted to a Z, this one, and that one. So I'll start you off with the 27. Z is equal to X minus mu over standard deviation, or what would be my X? 27. What's my mean? They told us the average in the story. 28. And what's my standard deviation in the story? And so that is negative 1.5. So negative 0.5. That's the Z. Okay. Let's do it with 31 also. Find the Z. 31 minus 28 divided by 2. Was that 3/2? So 1.5? Okay. So again, we're working on Z's now. We're not working, I know you're like, but why can't we work with normal numbers? Because it's just easier to work on a Z. The table, this green table is in Z form. So we need everything to be from the Z score. So now when I go to draw this picture, I have negative 0.5 here. Here's 0. Here's like 1.5. Where do I shade if I'm between? In between, yeah, okay. Now I want to find the area. I want to find the probability is the word they used. Same thing as area. So I go to norm CDF. What would be my lower Z? Negative 0.5. What would be my upper Z? 0 and 1. If somebody could type that out for me, I bet you the... Yep, 0.6247 or 62.47% of American households have between 27 and 31 pounds of newspaper garbage alone. That's crazy. I'm wondering if that's true anymore because, I mean, we don't even have newspapers really that much anymore. It's all online. So I'm thinking this was. All right, you try B right now. Try B. Convert to the Z. Draw the picture, put it in your calculator. Z equals 30.2 minus 28 divided by 2. And I got a 1.1. Is that what you got? Is there anything after the 1 or is it just 1.10? 1.1? Okay. When I go to draw this, because I think drawing is always going to help you out to understand, you're going to put your 1.1. So here's 0, here's 1.1 roughly. Am I shading, here's 1.1, am I shading to the right of it or to the left of it? And why? Because I am more than. So if you got that far, that's really good. Okay, now we have to type this in our calculator, norm CDF, because I'm finding probability, finding area. My lower Z, if I'm shading to the right, would be what? 1.1. What would my higher Z be? 99999. 0, 1. I get an area of approximately or percentage of 13.57%.
I got one right.
Doesn't that feel good, right? That makes sense. This is not hard. And I thank God I don't have to use the table anymore. It's like, boom, there it is. So much faster. I know, I'm going slow for a reason. All right, last two are the using the inverse. How do I know? You'll see why it's going to ask you to find a score or find an X. So you'll see those words. Let's see. So to qualify for the police academy, candidates must score in the top 10%. See how they gave you a percent there? They gave you a percent, a probability, an area. Okay.
All the same.
You got to score in the top 10% on a general ability test. Assume the test scores are normally distributed and the test has a mean of 200, a standard deviation of 20. Find the lowest possible score. So here's going to be a backwards way of doing this. So when I'm drawing this out, if I wanted to qualify for the police academy, I need to be in the top 10%. Where do you think I would shade? Right or left on this one? Doesn't that make sense to the right? So I would be like, this would be like probably very tiny over here. Like this is an area of 10%. Agreed? But I told you, you never work to the right when we're dealing with area. We always have to deal with the left area. What's the left area? You should know that one. What's this area over here?
90.
All right. So go to inverse norm, and it's going to ask you, what's the area? You're going to type in 0.90, and you're going to keep 0, and you're going to keep 1. And what's that give you as an answer? Go to like 2 decimals.
1.28.
Okay, that is your Z. Right here is 1.28, but that is not the correct answer. Because you no longer are, they want the actual lowest score that you can get. They actually want you to go backwards and tell me what the X was. What was the X that gave you a Z of 1.28? How do I do that? I just use algebra. I just use this formula again, X minus mu over standard deviation. What do I put in for Z? 1.28. What do I put in for X? I don't know. That's what I'm going to find. What's my mean? What's my mu? It said it in the story. 200. And then what's my standard deviation? Okay, so multiply these two together and add 200 to it. And tell me what you get out. 225.6. You need to get a score of 225.6 in the police academy to be qualified to move on further again. That's what that's saying. Did you think that was hard? It's a little backwards. So you put in the area, you find your Z, and you use the formula backwards. Let's do one more problem and see, hopefully this makes sense. For a medical study, a researcher wishes to select people in the middle 60%. In the middle 60%. Of the population based on blood pressure. Assuming the blood pressure readings are normally distributed with a mean systolic blood pressure is 120 and the standard deviation is 8, find the upper and lower readings that would qualify the people to participate in the study. So let me draw this for you. You are in the middle 60%, right here and here, yes? Isn't that what this story said? Okay, this is gonna be a little bit harder for you, some of you anyway, it's up to you how you figure. Again, unfortunately, our calculator can only do area from a left to a right. Listen to what I just said. That's the only way it does area. It doesn't do an in-between. It'll find the area if in between if I gave you the Z's, but not backwards. So it's not that bad though. How much is left for either end here and here? How'd you do that? It's not hard. 60, 1 minus 60 is what? 40? 40 cut in half is? So would you agree this is 0.2 and this is 0.2? I could find then this area and I'd find my 1Z. So let's do that. Let's inverse norm 0.20, 0.1, and tell me what that 1Z is.
Negative
Yep, it should be negative, yeah.
0.4.
Negative 0.84. Now, if you are in the middle, negative 0.84, if you're in the middle, take a wild guess what that Z is. Positive 0.84. because normal distribution is symmetric. So if that's a negative, that's a positive. Done. All right, so now how do I find those actual upper and lower readings? Because again, these are Z's, but I actually need to find that number. Well, you work the formula backwards. So you do negative 0.84 as your Z equals, what's your X? I don't know. What's your mean? What did it say the mean was? 120. And what's my standard deviation? 8. So negative 0.84 times 8, and then add over the 120. And I got 113.28. That would be this number. That's what that number is equivalent to, 113.28. Now, be careful. Do you think this would be, another 113.28? No. You still have to do the formula again, this time with a Z of positive 0.84. Same thing, now with a positive 0.84. So positive 0.84 times 8, and then add the 120 over, and I get 126.72. So this is what you have to be between. You have to have, in order to be a part of this study, you have to have blood pressures that's between 113 and 126. Okay. How do you feel? I know, you're like, do you want me to do a homework problem for you? What time are we out of here? 10 o'clock? I could do 2 homework problems for you. Distributed with a standard deviation of 1100, find these probabilities that a senior owes at least 1,000, that a senior owes more than 4,000, and that a senior owes between 3,000 and 4,000. Okay? So we're gonna work this through together, and I'll help you out. I'll read it again to you so you could understand. So the first one says the senior owes at least 1,000. The way you would write this is you would say, okay, I want my X to be senior owes at least. What does at least mean? Less than or equal to, more than or equal to, what does it mean? The least you owe is 3,000. So, okay, so what is the probability that you owe at least $1,000? Okay, so again, this is not a Z. You need to convert to Z's. Z equals X minus mu over standard deviation, or my X is 1,000. Let me go back in the story. The average credit card debt is $32.62. The standard deviation was 1,100. Tell me what that Z is. Should be negative. Okay. I have 06. Is it 6? Okay. That's fine. So again, if I draw this out, because I think it's always good to draw out so you can understand how big your area you're talking about here. 0 is here, -1 is here, -2 is here. So I should have a pretty large number if I'm more than that. So tell me what I type in my calculator. What are the 4 things I'm going to type for norm CDF because I'm finding area? What would be my low? Negative 2.06. What would be the high? None. What would be it after that? 0, 1. Punch it in. That seems right? Doesn't it? Look how much of the graph I've shaded. Yeah, so 0.9803, so about 98% of seniors are gonna have more than $1,000 of credit card debt their senior year. Don't be one of them. I know I did, I actually did. I did get into a habit, it's just what happens. And you're like, oh, $3,000, I can pay that off. Later. All right, part B. The senior owes more than 4,000. Ooh. X owes more than $4,000. Okay, I'm going to leave this up here, see if you can figure it out. It's this. This is going to be. This will be the same. That'll be the same. This is the only thing that's going to change to find your Z, because now you're working with 4,000. Make a Z, draw it. Tell me the area. More than. 4,000 minus 3262. What do I get? What's my Z there? I got 0.67? 0.671?
Yeah, if you run it.
Okay. My picture still pretty much looks the same. So, but again, 0.671, here's 0, 0.671, here's 1. That surprises me, actually. That's more than, probably a little bit less than a half. Well, what is that? 34, so probably 13.5, 20 something. Let's find out. 25? Okay, let's see.
25.11.
Norm, CDF, 0.671, 9999901, and you got what? 25?
25.11.
So 25% of all seniors graduating have more than $4,000 in debt, and credit card debt, not student loan. That's not what this question is saying. Just credit card debt. Right there. Don't be one of them, please. All right. I'm going to skip 6 because I think we understand what this is going, and I'm going to go straight to, 6C is what I meant, and I'm going to go just straight to number 29. But are you getting this right? Convert to a Z. Find the area. Convert to the Z. Well, now we're working backwards. That's right. I'm going to give you the area, you inverse norm, and you have to find the Z. We can do this. This is our last one. And then you have to do the rest of the homework tonight. This is called wristwatch lifetimes. My husband loves his watches, and they like to last for a long time. Did you know that the mean lifetime of a wristwatch is 25 months? How long is that?
That's literally.
Do you know when it says like, oh, you know when you're supposed to take the warranty for something? Oh, if you just pay $200 we will cover your warranty for 10 years. Don't buy it. More than likely, it's supposed to last for 10 years. My washing machine should last for 10 years, okay? So the lifetime is about 25 months for a wristwatch with a standard deviation of 5 months. If the distribution is normal, for how many months should a guarantee be made if the manufacturer does not want to exchange more than 10? Do you see that word? More than 10%? Do you see a percent? They give you the area then. They've given you the area. So now you're working backwards. Assume the variable is normally distributed. So more than 10%. My pen just is dying on me. There we go. So if the distribution is normally, for how many months should the guarantee be made if the manufacturer does not want to exchange more than 10% of the watches? Where would, oops, sorry, you don't even see it. Where would I shade?
To the left, right?
This is hard. Why to the left?
Because it's more than, so, like that.
But more than, I feel like I always shade to the right, right?
Wait,
No, you're right. I don't want to exchange more than 10%. So meaning I want 90% of the time for it to work. That's what I'm really looking for. I just want this little tiny portion here. I don't want to have to exchange. So now I go to my inverse norm. I do 0.1001 because it's already a left-sided distribution. And I let the calculator do all the work for me. What's Z gonna be?
Negative 1.2.
That makes sense. Negative 1.28. That is your Z, but you actually need to find the actual number using the formula. Z equals X minus mu over standard deviation. We have our Z. We don't know our X. Let me read to you what the average is again. The average, they say, is 25 months. And the standard deviation, I'll read it for you, is 5 months. So multiply, add the 25 over, and tell me what you get.
18.
So it's 18.6 months is where I want, let me go back and read it to you. how many months should a guarantee be made if the manufacturer does not want to exchange more than 10% of it? So about 18 months, he wants to say. And then after that, it's all yours.
Sorry.
All right, that's it. I've done 2 problems for you. You've got homework tonight.